Okay, we're going to get this motor back together. I want to get the workbench cleaned off. First thing I want to do is I just want to make sure that our electrical contact here for the start circuit is clean. And Abe Lincoln is going to help us out with that. Okay. We're going to slide him in between the contact here. I'm going to hold the contact closed and just drag that through a couple times. Get a new fresh spot. That's probably going to be good right there. If we wanted it super clean, we'd break out a Benjamin Franklin, but I think we'll be okay with Abe. Okay, so off camera, I did open up the start capacitor and gave it a visual inspection, looked at the connections and so forth. Everything looked good. We're going to be reusing the original bearings. So, I mean, they felt like they were completely failed originally when we took the motor apart. But it was just the old grease had solidified and put a coating of varnish on the inside of the bearings. That stuff was almost like a hardened plastic. It was just unbelievable how hard and solidified it had gotten. I had to actually soak these for a couple of days in acetone to get the last of that varnish and some of the really hardened on stuff out of there. And I've examined these really carefully, and they're like brand new, so they're going to be okay. I did look into getting new ones because this has extended race. They're not that easy to come by. They are available and they're rather pricey, so we're just going to reuse them. We can put, I'm sure we're in frame here. Let me move you guys a little bit. There we go. So we can put the front bearing on right now. The rear bearing, we have to do it in place because of the centrifugal switch assembly. So let's get the front one on there. We're going to repack these. I'll probably pack them with grease after we put them on because we can still get to them. And what we're going to use the Chevron SRI. This is actually what the manufacturers of motors use, or well, most commonly what they use. It's actually made for electric motors. It's a high temperature, super rust inhibited is SRI. Okay, yeah. So this is what they recommend for motor bearings. I've probably used the drop light more than any other method as a bearing warmer. If you got a large bearing, this will still work. You just got to put a couple rags over it to hold the heat in. Okay, I think we're ready. We got a pipe sleeve and a hammer just in case we need to tap it a little bit. All right, so we're going to be going this direction. There we go. All the way down. We'll probably give it a couple taps after it cools just to make sure it's all the way seated. All right, this bearing is good to go. Next thing we got to do is put the rotor in the motor. I got to take this spacer off. All right, let's slide this baby in here. Be real careful not to nick or damage the windings. There we go. All right, let's turn this way so we can see better. All right, so there we go. So the shaft's got to go through the switch assembly. Put our spacer on. Okay, and our bearing's warming up. All right, I just checked. We're at 140. I think that'll be hot enough. Or not. All right, we're going to heat it a little bit more. Okay, let's try this again. We're just a little over 150 this time. There we go. Put some grease in here while it's nice and warm. Okay, we got a couple shims that go down in here. Just gonna put a little grease on them so they stay put. There we go. And then we've got a little thrust wave washer. Do the same thing, a little bit of grease on it. And then we're going to put some grease in the cavity. We got quite a bit in the bearing already, so we don't need a lot. Because you want to have some airspace. I also put this housing on the light bulb to warm it up a little bit because our bearing is still just slightly warm. And if this was cold, it's not going to slip over. All right. So we're going to go like this. There. Okay, we already put some grease in there, and we got our shim is in there, and we left a little bit of airspace because we don't want it completely packed full. Sorry guys. There, how's that? I got to put the 2 screws in for the switch plate. Well, sorry about that. I did a terrible job of keeping the camera in alignment. The elevation screw on the tripod was loose, so it kept working its way down. Alright, so we've got these 2 screws that hold that Bakelite switch plate. Got to try to find the alignment here. Let's see, I'll get a light. Okay, I can see the bottom one a lot easier. Let's do that one first. That's the shorter screw. I need my helper Ethan here. He's the one that took all these off. Just snugging them a little bit. And then we'll give it the old tappy tap tap. Okay. Okay. That one looks like it started good. Check this front one. Yeah, it looks like it's going. Okay. I've had these where you get an alignment issue and they'll get caught on that register edge. It looks like it's going right in. Okay, and then before you get too crazy, check to see if it turns, and we're not turning, so something's not right. Let's tip it up and have a look. Yeah, it looks like it's going in. Let's give it a few taps. Okay, definitely got a problem. good. That looks good. Okay, so we're turning now. Still good. I think we were a little cattywampus. One of these registers was not aligning. All right, looking good. All right, I think we can go ahead and run them on down now. Okay, and we'll give it a few tappy tap taps, make sure it's seated. Okay. One last check. Okay, that one's good. Alrighty. Now, as long as it runs, I think we're going to be good. I've got a power cord jury rigged. Safety glasses. I've moved all the flammable liquids out of harm's way. And we got a fire extinguisher close by. Alright, well here we go. Nice. Alright, let's check our amp draw. Looks like about 8 amps. 10 amps is full load, but and of course we don't have a load on it. Alright. Sounds good too. Alright, let me turn this around. Okay, so we got a piece of tape on the motor shaft. Let's see which way it turns. Okay, so looking from the back, it's going clockwise. Alright, so I'm going to switch those start windings the other way around. Alright, I've flip-flopped the start windings. Let's see what happens. Oh, nice. Counterclockwise. Sweet. And we'll check our amperage running in this direction. Doesn't matter which wire we use. 6.7. Alright, well I've been running this for a while, probably 10 minutes, and I've reversed it a couple of times. Amp draw is the same, both directions. I'm going to call this a win. So we got a good motor. I'll probably give it a nice paint job off camera, and then I'll put it away until we're ready for it. Got most of the paint off, mainly just using oven cleaner and a little bit of wire brushing and scraping. But oven cleaner, it took off 90% of the paint. Alright, well what I'm going to do now is I've got the shop crane set up. I'm going to lift this up, get it off the stand, try to get it on its side, I think, because I want to split this base unbolts. So let's see how that goes. I think I'm going to take my grinder with a flap disc and see if I can improve this transition a little bit before we split the housings. This is interesting. I wonder if maybe they had a riser or a gate right there that they milled off. Well, that's a little better. We're probably going to be doing a bunch more of this grinding, but at least that was easy to do. Well, not easy. That was easy to do right now while we had the angle here. Alright, got this suspended. So we got 4 bolts that hold the base on. And tight. Sort of did. Okay. Just looking at our contact pattern, and it's not horrible. I mean, it looks like it was light here and over here. And the base is as machined, and pretty much the same story here on the column, although it looks like they may have done a little bit of scraping right in here. So I think we can improve this a little bit. I don't know how crazy we'll go, but yeah, we'll probably tune this up a little bit. Looks like they had a big blowout right there. Oh well, it lasted all this long. We're just going to leave it the way it is. But we're going to clean up. Boy, there's some really nasty flashing in here. I don't know how well you guys can see that. I'm definitely going to grind all that out. It's ugly. I thought I'd do a midday update just to kind of show you guys where we're at. So I want to get this degreased. We've got rain coming tomorrow. In fact, it looks like it might even be here this afternoon. So I'm going to work on this outside with some purple power and a wire brush and see if I can get that cleaned up a little bit before the weather goes bad on us. I've been getting everything cleaned up. I got to do a little bit on that big pulley there. Most of our other parts are looking pretty good as far as at least the initial cleaning. There's a few items that I want to do some more final polishing on. And then of course we've got the motor over here. I want to get this motor done, get it off the bench and just, you know, tucked away somewhere so it's out of harm's way. I ordered bearings for it, and those aren't going to work. So it was kind of a misleading ad. I thought I found the deal of the century. They're actually bearings for a mower spindle, like a zero-turn type mower. And the part number, it looked like they were the same ones we needed for the motor. So yeah, these bearings, and I've got them soaking outside right now in solvent. But yeah, they're not the easiest ones to find. I mean, they are available at a very high price. And there's also quite a few new old stock ones, but I mean, they're old, and I don't know if I trust them or not. So, long story short, the original bearings I think are actually okay. They were just packed with dried and solidified grease, and first I soaked them in regular solvent. That got about 80% of it out. Then I soaked them in white gas. That got about the other 10%, 90% of it out. Now I got them soaking in acetone to try to get the last of that varnish out, and I think they're going to be okay. We've got our other bearings coming in, or they're here, for the spindle and the counter shaft. We've got our felt is here. We've got to cut it into strips. The old felt, oops, don't trip over the pulley. The old felt is actually cleaning up, so we have a backup plan in case I can't cut that new stuff to size. I'm going to have to use a razor knife and a straight edge and try to, it's the right thickness, to try to get it to the right width. And this is, I got this from Northwest Piano Service, and it was cheap. So this is buffer felt for the strings. You know, if you look inside a piano, they've got under each string, there's a little buffer that comes up with felt that dampens the string, and that's what this stuff's for. And it was like $6 or something like that for this whole roll. Yeah, because I was trying to find this stuff, and to get it in this thickness is not easy. And this turned out to be a really good source. Okay, I'm gonna get this thing degreased before the weather goes bad, and then we'll pick it up from there. When I started to paint this pulley, I noticed it was way out of balance. I had a piece of dowel, wood dowel, and a couple milk crates holding it up, and it kept spinning to one side. So I've set up my balance rig here, and I've got a video of making this, and I'll put a link somewhere in the description. But yeah, this thing's got a pretty good out of balance condition. So now's the time to take care of that. And I did also rotate the shaft 180 degrees to make sure that, you know, it wasn't being influenced by possibly a bent shaft here. It's just a piece of stock out of my bin. But yeah, it's quite a bit out. So I started sticking some magnets on, and I ended up with this particular stack up right here. So there's a couple of washers, a couple of magnets, and let's put it right on the high mark there, and let's see how it does. Not bad. Okay, we'll give it a few different rotations here. That's going to be good enough for what it is. So what I did, let me move you guys a little bit here. I got my Amazon scale. And I have a more accurate scale for when we do this for the final fit up. So I got 0.6 of an ounce. So I just took a piece of key stock and just gave it by hand, just a matching radius over on the grinder and the belt sander. And we're pretty close. It's 0.7. So I'll fine tune this, and I'll have to kind of allow for epoxy. I'm just going to epoxy that on. Yeah, and we'll get it glued on there and see how we do. I have a better scale than this. This is just a quick one. I'm going to use a little balancing scale to get it correct. Yeah, my first thought was just to drill out some material to lighten up the heavy side. But there's not a lot of meat on this pulley, so I'm electing to just add a weight instead. This is funny. I couldn't figure out what the heck was wrong with my scale. Well, I had it down here on the bench, and the little holder here is brass and aluminum, so it was only about maybe 3/4 of an inch off the bench. But those magnets are so strong, it was still pulling. It had about 100 grams of pull down toward the bench, and then as the scale would go up, it would get even worse. So I couldn't get the thing to balance. But all right, so I got it up on some wood now, so we're working okay. All right, I've been grinding away on this, and I think I've got it where we want to be. Okay, we're balanced right now. Let me take the weight out. See where we are. Let's give it a little bump here. There we go. So we're a little light. Let's see how much we are. 5 grains. Not even 5. 4 grains. We're going to be adding a little weight with the epoxy, so that's a good starting point. All right, I'm going to get that glued on. I've got to grind that paint off a little bit so we get a good adhesion. I'll do that off camera. All right, so I got our weight epoxied on, And I did have to fine tune it a little bit with the Dremel tool. It was just a smidge too heavy, but let's give it a test here. Okay, let's try this side. It's funny, anybody know why you always get a little rollback on your balance stand? See that it always rolls back the opposite direction just a little bit. But anyways, that's plenty good for our balance. That's going to be way better. Dabbling with some nickel plating, first time ever. Got our little science shop set up here. Power supplies down there. This is just a test piece. It's been going about almost a half an hour. We're going to pull it out and have a look at it. Brought it out to the sunlight. So we're getting some streaks, and I think that's happens when you have too much power and you're getting too much bubbling. So I'm going to try a different power supply. Okay, I went to a smaller power supply. This one current limits at about 100 milliamps, and I'm liking it better. We don't get the severe bubbling like we were with the other one. It's more of a finer bubbles, so hopefully that'll help reduce those streaks. The radio on, so I had to narrate this part. So the pulley on the left, I nickel plated. That took me 3 days. It was quite an ordeal, but it turned out fairly decent. Okay, and then this one on the right, all I did with that was polish it with mainly with a wire wheel, and then I just gave it a clear coat. A much easier process. So yeah, we're going to stick with the clear coat on the other pulleys, and I'll try to show some more of the nickel plating experiments in the next video.